Hi, I'm a software engineer, a specialist in high-performance computing, and recently moved to Elixir, the infrastructure in Europe for life sciences, to make myself useful. I know about the technicalities, so make it useful for some people who can make use of it. So today I will talk to you about Docker. Actually, this training we used to give in 3 full days. So I'll try to teach you something about everything so that you know how to do basic things and you know how to find the materials to do advanced things. So first introduction about Docker. This problem we used to have DevOps. So in the computer world, there are people who develop software. Those are developers. And there are other people who maintain the systems. Those are called operations. How many of you here is developing software? And how many of you is maintaining the system? Okay. So probably you know about this problem. A developer develops software. You want to use the new languages, you want to use Go, want to use Python, want to use everything that appears, everything which is easy to use. I want to develop things and want the system administrator to install whatever he wants. And the system administrator, you have a system, you have a software that is installed, it is working. You want to work with the thing that you used to work yesterday. You want to work this year with what you used to work with last year because it is working, it doesn't cause problems. Because if a system goes down, no one will ask the developer, but everyone will shout as the system administrator. So this was a problem and still a problem. So always the operations are, used to be deaf for any new changes. So this how is it in brief. The developer wants a change, wants new things, and the operation wants stability. Docker is a new tool that uses Linux containerization technology. This is Linux, this is Docker, and this is Go, the programming language where Docker is developed. And Docker is not a technology, it is a platform that uses the Linux containerization technology. So Docker is a company that made a platform for users to be able to create and run containers in a user-friendly way. There are other companies who use containers, and there are other different containerization technology in the field of Linux, like LXD, LXC, and others. And to give introduction about containers and why they are useful and how they are useful, this is how the image was before, an application server. You heard about web server, database server. So that server is a machine which is connected to the network. It has an application. So a database server, a server that you install MySQL, you install Oracle SQL Server, and it has the database engine and the database files. This is a lot of cost and maintainability. Then the concept of virtual machines. Virtual machines, they were first introduced in the 1960s. So it is very old concept. But what the new concept is cloud computing. Virtual machines, you have a file that contains a guest operating system, and you can run it on any other operating system. You can have a Windows virtual machine running on the Linux system. You can have a Linux virtual machine running on a Windows system. You can have different virtual machines of different systems running on a system that has hypervisor or virtual machine running. How many of you are using virtual machines or used virtual machines before? So probably you know about that. And recently was the concept of cloud computing, pay as you go. So you pay to a company, they run your system on their virtual machines. You don't install the virtual machine in your system, it is on the internet somewhere. You rent these virtual machines from them. They are responsible to maintain your software, to maintain virtual machine, and they have the different concept that we have seen probably in previous presentation. Infrastructure as a service, platform as a service, software as a service, and there are other things like data as a service. You will find everything as a service. So containers. For virtual machines, it is very flexible. So the example that I have used in a previous presentation, like BioLinux. BioLinux is a virtual machine which is based on Ubuntu that has Galaxy installed, that has R installed, that has some bioinformatics software installed. It is a package of software, about more than 20 or 30 software installed in a package. This is a typical case for a virtual machine. But what if I want to share one piece of software that uses only 50 megabytes on disk? Do I need to have a whole guest operating system which have 700 megabytes to install 50 megabytes of software? Not reasonable, right? So this is where containers are useful. You want to install one piece of software, two pieces of software that are very small, and you don't really need to consume a guest operating system that will consume your disk resources and memory resources just to install this small piece of software. So you have the application, you have the binaries of the application, and it does not have own guest operating system. It works on the kernel of the host. So it works in your kernel, but you need to have a Linux kernel. This is all what you need. And each container has its own root file system. So /etc, /dev, /bin, every container has its own. It is different from the host. But the kernel, for example, /pros, this is inside the kernel. So this will be from the host, not from the container. And it was proven to be very efficient in terms of speed. This slide I bought from the National Energy Research Scientific Computing Center at the United States. And they have made some experiments with Linpack software for linear algebra. And this is the native installation, installing the software directly on the server, in the system, and installing software using a Docker image, and installing software using a virtual machine. And you see here the speed of the Docker container is almost equal to the native installation. The other thing which is, in addition to being very lightweight and very fast compared to virtual machines, the Docker file system, layered file system. So when you start to install a software, you get a base image. You want to install it on an Ubuntu platform or a CentOS platform. You know, people in different fields of science, they have different interests in terms of the platform. Bioinformaticians, all of them almost use Ubuntu. Physics people, they use CentOS. So when you want to install a piece of software, you would like to use apt-get or you would like to use yum, for example. This is what you are used to. So if you want to have an Ubuntu-based image, you can install Java, Apache Tomcat, and install other software instead of it. When you install software, another software, and each time you create a new image, you don't double the size. So here, if you have an Ubuntu image, you install Ubuntu plus R. R is 50 megabytes. So Ubuntu plus R, 250 megabytes. You want to install another Docker image, Ubuntu plus MATLAB. MATLAB is 50 megabytes. So it becomes 250 megabytes. All the three, if you have them on the Docker repository, you don't say 200 plus 250 plus 250. No, you say 200 plus 50 plus 50. Because Ubuntu is only one. It will not be repeated. But if you have them in a virtual machine, first you will have Ubuntu as 700 megabytes, not 200. Then you will have 700 plus 750 plus 750 in your disk. So this is the other advantage of using containers. So they are more lightweight, no need for a guest operating system, less resources, greater portability, and faster. And in short, it is build once, run anywhere. If you build a Linux container and you build it as an image, and it runs on your system, it will run on any other Linux system with the proper kernel. And this is similar to Java. You remember, this was first introduced by Java. Write once, run anywhere. So it is similar to Java in this context. Okay, ready for fun? Access your virtual machines. It's a bit not complex, but first you will need to. All of you received the email for the PIM file, right? Anyone didn't receive it? So you will use SSH using this PIM file and accessing using this username, access this IP address, and this will be your entry point, like a proxy. And then you will have 20 virtual machines from 85 to 77. The username is also cloud user. So you will log in first to this virtual machine, which has the IP address, and then from this virtual machine, you will find that file again in the home directory and use the same user to log into your virtual machine. Yeah. Okay. So now let's install Docker in the virtual machine. How to install Docker? Open Google, write install Docker or Docker install. And then the first link, you will find a list of operating systems. This virtual machine is a CentOS virtual machine, so you choose CentOS. Okay. So if we write here install Docker, first one, then choose CentOS. Follow the steps. First, check your kernel version. This is how you check your kernel version. Make sure that it is 3.10 or higher. Second step, you install with yum. It is equivalent to apt-get if you are using Ubuntu. I choose the platform to be CentOS because CentOS and Red Hat are the best Linux release that works with Docker. But of course, you can install it in Ubuntu, and you will learn that you can install Docker machine even on Mac or Windows. So sudo yum update. This username, cloud user, it has sudo, right? So you can run sudo. And then copy this command. You need to add this file to the yum repository. So you just copy and paste this. And then sudo yum install Docker engine. So you can have this page, of course, open in your computer. Just, After installing the Docker engine, Docker runs as a service on the machine. So this is how you start a service. Sudo service docker start. And then to make sure that Docker is properly running, there is a very lightweight image. It's called hello world. To test that your Docker is running, sudo docker run hello world. And you should get this output. And actually the slides are on GitHub, so you can download the slides. And of course you can have this slide if you forgot how to log into the machine. So you can just get all of the slides that you have now. How many have reached to Hello World output? Very good. Okay. Now, this is a surface that runs a Linux machine. Now, if you want this surface to run whenever you start your machine, then This is another way of installing using a script that you already installed. Yeah, first, if you want to run, now we have been running Docker using sudo, so you have to be root. If you want to run Docker just from that user that you have without running sudo, you need to create a Docker group. So you need to say sudo group add Docker. And in some versions of Docker, maybe in this last version, you will find that the Docker group already exists. So just run this command to make sure. If it exists, then proceed to the next stage. Sudo usermod -ag capital Docker your username. Your username is called cloud-user. So in this command, you are adding this username to this group Docker. Every user who is added to the Docker group can run the Docker command without sudo. So for system administrators, you have to be very careful whom to add to the Docker group. And then after you add yourself, and yourself means cloud-user, now try to run again Docker run hello world without writing sudo before it. Okay? How many have managed to run Docker run without sudo? The last step in the installation is just this command to make sure that the service will start whenever you restart the machine. Sudo check config docker on. Means that when the machine starts, automatically start the service, so that you don't need to say service docker start when the machine starts. Okay? So this is the end of installation. Who made everything in the installation process? Unfortunately, I'm not allowed to share this tutorial with you. I'm allowed to present it, but I'm not allowed to copy it to you. But what you can find here, the Docker training, you have, this is the instructor-led training if you want to pay someone from Docker to teach you, and this is how I got these slides and got authorized to teach it to other people. And then there is the surf-based training. And those are 3 videos which are very useful. There's something. So as you see, 46 minutes, 59, and 76, 67 minutes. And the first one is the most fundamental, and the last one is the most advanced. And actually, all of the training slides, they are described in these videos. So you will not get the slides, but the videos contain all of the slides. So, Docker images, if you're working with virtual machine, when you run the virtual machine, it is called a virtual machine, and when you have it in disk, it's called a virtual machine image. You can have it as a virtual disk, or you can have it as an OVA file or OVF file where you can share with people. So the same with Docker containers. When it is on disk, it is called an image. When it is running, it is called a container. Yeah. So you can search for images on the Docker Hub. And there is a link on the GitHub repository for the Docker Hub, or just write Google Docker space Hub. And then open the Docker Hub. Then you get an interface like this one, and then you can search for software. Think of any piece of software that you are using or within your group or your personal use, whether you are working physics or bioinformatics or whatever. Probably you will find one or more images on the Docker Hub with this software. And this is how to search from your command line. So now try to run this command. Docker search Java or any other software from your virtual machine. And it will list the images that match this search. So this is how you find images on using the web interface of the Docker Hub. And this is how you find images using your command line interface also from the Docker Hub. So when you say Docker search, it will connect to the Docker Hub and search there. So here there are columns, official and automated. Official here means that this is the official software of that company. So Java, who owns Java? Oracle, right? It would have been a company called Sun, and Oracle bought it. So this is the official repository for Java made by Oracle. Other software is owned by other people. So if you find this official is okay, so this means that it is made by the company or the vendor of that software. Automated build, we will talk about it later. It means that you have a Docker file, which is a script, and this script is available on GitHub. And whenever the founder of this software changes the building script, the image will be built. This is good for security, so that you know how this image is built. This is the script, how this image was built. So if there is any malicious code or vulnerabilities in this image, you will be able to find it. So it is recommended always to use the official, if there is an official image, and to always use the automated build. Because if there is no automated build, then you get the image, you don't know what is inside the image. You don't know how this image was built. You don't know what types of software are there, because you cannot look at the building script. So always choose the image with automated build. Okay, so this, for example, if you search for Java, you'll find many images made by other people, and you'll find the official. Now, this is the second part of the hands-on. Create a Docker Hub account. It is not like Amazon. Amazon always asks you for the credit card information. It will not ask you for any credit card information. So go to hub.docker.com and create an account there. Okay, who is done with creating an account? So for every account, you will have a username and password. And the username is the ID of your repository on Docker Hub. And you can create a number of repositories in Docker Hub if you want, but you have to create one repository per email. So if you have 10 emails, you can use them to create 10 repositories or 10 accounts in Docker Hub. So for example, one could create his personal account and his company account. So you as a software engineer, this is your account, and you as a regular user, this is your other account. But don't create too many accounts, because it's not. So in this place, you get a free space where you can upload your images and share it on the public or with other people. And up to now, there is no space limit for how much you can upload on Docker Hub. Of course, this will not continue when people start using Docker more, but at least for now, there is no limit. Now, how many of you have done with creating an account to Docker Hub? Anyone having trouble with that? No? Okay. Now you have an account in Docker Hub. Now run this command, Docker images. This will show you how many images that you have locally on this machine or the virtual machine that you have. When you run this command, if you don't have any images, you will have only the hello world image that we have used to run to test Docker. Did you see the hello world image? Okay. So this is the image tag. And it is based on the fact that Docker Hub looks like GitHub in version control. So in GitHub, you can have many versions or SVN. So the latest one means the latest version of your software. You can have 0.1, 0.2, 1.0, whatever. You can have hundreds of different releases, not only with numbers and letters. You can use any standard for software releasing. And the last one is called latest. So if someone wants to pull a specific version of the software here, he has to use the tag. If he doesn't use any tag, then it will become the latest. And this is the image ID. So this is you put the image name, and this is the image ID. The ID is unique per image, but some images can have the same name with different release. But the ID is always unique. And this when the image was created, and this is the size of that image. Okay, so for Java, for example, there are different releases of Java. So these are the tags of the Java release. Okay, now let's get an image from the Docker Hub. Docker pull, you are pulling an image from the Docker Hub. Now we want to get a base image of Ubuntu, meaning that Ubuntu file system without anything installed. This will be about 200 megabytes. So a plain Ubuntu image. Of course, an Ubuntu virtual machine is about 700, 750 megabytes because it has also the guest operating system. So this is an Ubuntu Docker image. So you can pull it, Docker pull Ubuntu. And this will get you the latest version of Ubuntu. If you want to get a specific version of Ubuntu, you put the tag. And this is how you put the tag. Ubuntu : the version. 12.04 or 14.04, whatever. This if you want this specific version. So now try to pull Ubuntu to your repository and then run the command docker images again and make sure that Ubuntu exists on your virtual machine. Okay, now you have a base image. Let's try to build our own image, install software and make our Docker image. So now we'll go through two main ways of creating your image. First, this is your base image. For example, Ubuntu or Debian or CentOS or whatever. And then you can install a software. This will be another layer that you add to the image. Now you have an image with Emacs and Debian. Then on the top of that image, you install Apache. Then you have an Apache and Emacs and Debian in one image. And then you can open the terminal with the image, and this will be a writable layer. So all of the layers below, it is read-only. So you have some files in the root file system of Ubuntu. For example, you have something in /etc, which contains the system release, and /bin contains the basic binaries. And those things are read-only. So when you install a software, if you need to add something to one of these files, this file will be copied from this layer here to the layer where you are in now. So there will be two copies, one copy down in the base image and one copy of the file here where you are going to modify. Anything that you will add, new files, it will not need to copy anything from this layer to that layer. Things will be copied from this layer to that layer only if you are going to modify something from the bottom layer. Then this file will be copied and you will have your own copy in your layer. So this is how the layered file system works. And this we have shown before. So now let's take an example of building images from here. I made it more simple for you. Method number 1, Docker run and get an interactive access to the image. Now, the image, the container runs in the memory, and you get the hash, you get the root access to that container. Now deal with it as a virtual machine or as a machine. And install your software the same way you install it on the machine. Yum install, apt get install, whatever. And after you finish installing your software and testing and everything, exit from that session, the same way that you exit from a session to a machine or virtual machine. And then commit these changes to disk. You will create a new image which includes the software that you have installed. Another way, starting from this base image and write a Docker file, which is a script, and build from this script to the image. So now let's try with the first method. Now Docker run, and these two options, -t, -i. -i mean I want to have interactive session with this container when it runs. And -t mean that it will get the TTY, so that you get the output of the stdn. And this is the version of Ubuntu that we want to work with. So Docker run -t space -i space Ubuntu :14.04. Now you will get root at blah 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 blah, and you will get the hash. And this blah 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 is the ID of the image, which will be the host name of the image or the machine name of the image, of the container, sorry. Okay, who managed to log into the container now and got the hash? Okay, now run these commands. Let's install these two pieces of software. Install curl and vim. So you need to do apt-get update first. -y, because if you don't update, you will not be able to be connected to the repository. There is a space here, by the way, but the PowerPoint sometimes doesn't show it. So apt-get space update space -y. And after that, apt-get install -y curl -y vim. So the update might take about 2 to 3 minutes, I think. And then each of those takes about a minute. This is the second step. Now we want to commit these changes and make an image out of it. So you run Docker commit, and this ID must be the same ID as the host name of the container that you have just exited from. So you have to copy it from here, which means that I want to commit the changes that happen to this container. And here your username, you remember when you registered on Docker Hub, which username have you used? Use it here, because we want to push this to your repository. So write your username on Docker Hub /curl vim, or if you want to name it something else, and put a tag for the version 1.0. If you don't put a tag, then it will be tagged as latest. But we want to put a tag because we will build the same image in another way. In the other way, then you will have two images.
So
Sorry?
Does this command added to the repository?
No, it is not added now. Now it is only on your machine. To be added to your repository, you have to log in.
Yeah.
And we will see how to do that. Yeah. So how many of you have done the commit? Okay. Now, let's try to run the image and see if it has probably the software installed. Oh, sorry, it is not test, it is the same name here. Now, Docker run, the image name, your username, /curl_vim, and now this. So this is how you run the container. You give the image name with the tag, and then this is the command that you want to run. Curl -- version to make sure that curl is installed. If you get that output, it means that curl is installed. If it is not installed, then it will tell you command not found, right? So after you make sure that curl is there, now I have created this image. I want to push it to my Docker repository. Then you need to log in first. Docker login. When you say Docker login, it will ask you for a username and password. Then use your username that you registered on Docker Hub and the password that you have on the Docker Hub user. So your username and password on Docker Hub. After you are logged in, now you can push this image to your repository. So you say Docker push and then the image name with the tag. Then it will start pushing this image to your Docker repository. Those who managed to push, now open the web browser and go to Docker Hub and go to your Docker repository and make sure that this image exists on the Docker repository. You will find the image there with the name that you given to the image and with the tag that you specify. So now, if it is public, anyone here can pull the image of anyone else, because it has a unique identity within the Docker Hub. So any one of you can pull the image of anyone else if he knows the username /curl_vim and run it in the same way. So now you have published this image to the world. And of course, you can make it private as an option with Docker Hub. So this is how you create an image and push it, publish it. The other way of creating images is using the Dockerfile, and this is the more standard way. So the Dockerfile is a script where you build the Docker images from. It will build it the same way that you have done interactively, but this allows you to give this Dockerfile script to anyone else, and this person can build it from that script. And it is also more standard, so that people who get your image will get the history of that image, what type of commands that you have run to build this image. So it will be, your image will be more trusted. So we will go through the commands that you include in this script. So it is a script, means that it is a text file. So this is how you include comments. You put hash before. And this is how you start from the base image. You say from, capital letters. All of the commands are capital letters. From Ubuntu, :1404. And this is how we said in the beginning, Docker run Ubuntu, and then we got the interactive login. So if you want to build it from the script, so this is where you start. And then you want to run a command, apt install vim, apt get install curl. So this runs as a command. Yeah.
Is there a reason why you didn't use updates?
Sorry.
You first did get updates. Is there a reason why you didn't?
Those are examples, but actually you need to include the update. So those are just examples. Doesn't mean that you can use this specific text. Yeah. And also, if you do it here, something will not work. Why? Because here there is a very important thing to take into account, and this is an important difference between building from interactive building and building from a Docker file. You remember when you, for example, when you say apt-get install something, you will get always a question, yes or no. And this requires that you give y or n. You cannot use this in the Docker file because you need to make sure whatever commands that you write in the Docker file will not need interactive login from the user. So you have to put -y so that it will not ask for interactive prompting from the user. Because if there is anything that needs input from the user, the building process will fail. So you have to make sure that every command that you put inside the Docker file can run without requiring any interaction from the user. So those are examples of the from statement. This also doesn't mean that you can include multiple from statements. Actually, technically, you can do this, but this is not recommended at all. So this, if it is official, this if it is a repository made by someone like yours, and this if it is a local registry in your system. Okay? So this is an example that you can do in a Docker file. So let's do our example again using a Docker file. Now create a directory. Now you are inside the home directory of the user, cloud user, right? Now make a directory called curl vim. This is the name of the image. And inside this directory, make a file and you call it Dockerfile, and it has to be like this. Docker with capital D and file with small f, and it is one word. Dockerfile. It has to be like that. Okay? And open that file using any text editor that you like, Nano or Vim or whatever, and write these commands in that Docker file. From Ubuntu 14.04, maintainer is an optional command that you write your name, that you are the one who maintains this image. So anyone who you are going to share this Docker file with knows if this person has some error or some trouble, who to contact to ask questions. So if you don't want any headache, you can just skip that one. And then the commands that we have run in the interactive login, apt-get update, and you have to include -y, and apt install curl -y vim -y. Okay? Now, after you saved this file, say docker build -t, mean the tag of the image, write the image name. How did we call it before? Your username curl vim 1.0. Now call it your username /curl vim 1.1, for example. So this will be the image name here. your username / curl vim .1.1. And then the last argument is the directory that I asked you to create now, the directory that contains the Docker file. So you are telling Docker, build a Docker image from the Docker script file, which is in that directory. So you can do that if you are in your home directory, or you can cd to that directory, and here you can include only dot at the end. So the Docker file is here.
When we pull these images out of the internet, where are they stored? I mean,
they are stored in the Docker Hub. This is a public repository.
No. I mean, if you take an image from there,
yes.
Where are they then? If you want to clean them,
there is.
You can try all these images and the disk is filling up.
Yes. This is a very important question, especially for operations. There is a command called docker info. If you run docker info, you will get where the things are there, and it will be /var /lib /docker.
Okay, and they are owned by the.
They will be owned by the root.
Yeah.
They will be owned by root.
Okay.
Okay. So one thing that you can do in operations, or what I normally do, is that I move these things from /var /lib /docker to a place where it can be for maybe a shared file system or something, and create a simulink in /var /lib /docker to that place. Then you can scale, because normally the root directory is not big in that. Yeah. So, who started the building process? Okay. Now we'll find an output like this, sending build to context to the Docker daemon. So this file, the script, is sent to the Docker daemon, which is running in the background as a service, telling it build this script. And then step 0, this is the first line that you have written. It creates a layer over the Ubuntu. So this is the first writable layer that it gets the update. And this is the ID of it. And then for the second command, which in our case, it will be installing curl, you will find another ID of another layer. And the second command, which is installing vim, you will find another ID of another layer. So for each run command, it creates a container, a layer over that. So who got the building process successful? Okay. Now, what is the problem with this building? Now we installed curl and vim, but each one we installed it in a separate run command, which means that it will create for each one a separate layer. This is memory consuming, actually. The best way to do that is to do it in the following way. So this is what we have done, and this is how it should be. You can include both of them in one run command, because in Linux you can use this double and sign to run two commands in the same line. This will run install curl and install vim in one layer, so it doesn't consume a lot of your memory, because each layer will consume memory. Now try to go and modify your Docker file, and instead of having it like this, put it like this, having both installing curl and installing vim in the same run command.
When you want Dockerfile, you used to have a limitation that you could only do 228 commands. Is that
yes.
the case?
I think this was in Docker 1.8. Maybe they have.
Using this, making long.
Yes. Yeah. But when you use the and, you can include 1,000 commands if you want. Yes. So typically, if you are installing, for example, many pieces of software, you include all of the related commands in one run. so that you create them. You create one layer only for them. Now, after you modified your Docker file, run the build command again, the same command that you have run. Docker build dash the same image, the same tag, and the same dot or the directory name. And watch how the build process will go. You will notice something, that one of these containers will disappear, because when you apt get install curl and vim, they will be in one layer. So you will not have a separate layer for each, or a separate step for each. They will be running on one step. So this is called best practices for building a Docker image from a Docker file, to reduce the number of run statements in the Docker file as possible. Because each layer will consume from your memory while building. Of course, at the end, the resulted image will be the same size, but the building process, your memory might not handle it if it is too much. To reduce the size of your image, the first best practice to do is first to choose a very lightweight base image. For example, there is an image called BusyBox, and this is a very lightweight image. So this is even less than Ubuntu. And there is a new support for something called unikernels in Docker, which is another technology other than containers, but it is similar. So a unikernel has the base image very limited size, about, I think, 30 megabytes for the base image instead of 200 megabytes of base image in Docker, for example. So this is the first thing. Choose a very lightweight base image as possible, and try to install one tool per container. Don't install a lot of tools per container. If there are some of them which are very related and dependent and they cannot run without each other, then you have them in one container. But containers are not made for something like BioLinux. A virtual machine is good for that. So containers are not alternatives to virtual machines. Virtual machines has their own purpose and they are keeping their position. And containers have another purpose. Container is made ideally for one tool per container. Virtual machine, a package of tools per virtual machine. Yeah? You have a question?
Yeah, one question. I don't know if you're going to maybe say that later, but if you want to reduce the size, you should also remember each run command is a separate layer. So when you run the apt update, you download the apt cache to your local system. You need to remove that at the end to clean up your images before you carry on to the next. Or else the bloating from a previous layer would be added in the end.
Yeah, but when the final image is built, all of the intermediate containers will be removed. They will not be inside the image, but they will be stored in the cache of the system, actually. Yes. And there is a I don't want to go through the details here because of the time, but I will say it very quickly. If you rebuild the image, for example, if you change one of these commands, now we have 3 commands. One is from, and one is run to install curl, and another one is run to install vim. In the first version, when you had them in 2 runs. If you want to modify only the last one, so instead of installing vim at the end, you want to install R or install Emacs or whatever. And you build the image again. The first commands are the same, so it will not go through it because it is stored in the cache of the Docker engine. And it will build only the last one. So by default, all of the intermediate containers are cached in your system, so that if you build it again, it will be in the cache. There is an option, it's called --no cache in the build, Docker build. So --no cache. I'm not sure if it is here. I can show it to you. Yes, here it is. this tells the Docker engine don't cache any intermediate containers. So if you rebuild it again, it will build it from scratch. So this cache is useful if the building steps are 100 steps, for example, and you are only modifying a small command number 60 or command number 90. So instead of building from step 1 or step 0, it will build from step 90, which will take less time and resources. So this is the cache benefit. But of course, it will take from disk. If you worry about disk, then you always do no cache. Now to the next step. How many of you have managed to run all of the build commands that we went through? Okay. Now this command is very important. Docker history. Docker history will tell you all of the commands that you have used to build this image. And this command will work only for the images that have been built from a Docker file. It will not show you anything if the image was built using interactive logging. That's why it's very important when you pull an image and you want to run it on your production system, you need to make sure that this image is built from a Docker file to get the OK of automated build at the end. So it will tell you the guy who built this image what commands were executed. So try to run Docker history for the image that you build using interactive logging, and run the same command for the image that you build using Dockerfile. And notice the difference. So now you have an image called your username / blah 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 tag, I think 1.0 for the interactive login, and the other one was 1.1 for your Docker file. Or I don't remember, so you can see what did you call them. And the Docker history will not include only the commands that you executed, but it will include also the commands that have been made to run, to create the base image. Okay? Did you notice the difference between the outputs of the Docker history? Now, another thing in the Docker file, CMD instruction. Now we have taken the from and run, and this is the third instruction, and maintainer, and this is the instruction CMD. CMD means the default command that you need to run. If you remember, when we wanted to try the image, we entered docker run, the image name with tag, and then curl, because we had to enter a command. Now, if you want to make curl as the default command, you use the CMD command for that. So open your Docker file and add at the end CMD curl. So here it is CMD ping, which means that for this image it will be ping command. So you add at the end of your Docker file CMD curl. And after you do that, in this step here, try it again, docker run your image name with the tag, and say -- version without including curl after you build the image. So actually the command thing, it will work for the curl, but if you give arguments, it won't work. So if you just run it, it will tell you that it will run the curl command, and it will tell you you need to enter arguments like -- help or whatever. So just run it without including anything. Because I tried it with Ping, but with curl it might be something wrong with the format of the arguments.
So if you want to use curl as your default binary, should you use entry point instead?
Yeah, the entry point is another
Entry point,
solution.
/
Yes.
help, and you get the help from
Yeah.
curl.
So now if you still want to use Vim, you can run the same image, which has the curl command as the default, and instead of not entering anything, you enter Vim. So Vim will still run. Okay? So the CMD attribute in the Docker file, it sets a default command for you. But you can still override this default command if you enter any other command. So curl will be the default command if you don't enter anything. But if you enter another command, it will overwrite it. So if you enter Vim, if you enter ping, if you enter host name, if you enter date, time, any command that you run in Linux, it will overwrite the curl. Now there is another way if you want to enforce. For example, this container is for this tool. The command must be this one. You use another attribute called entry point. So if you use entry point, this will enforce that the command must run, the user must run this command in the beginning. You cannot overwrite it. So this can be used as an alternative to CMD. This enforces. Anything you will enter after the image name will be an argument for this command that you write in entry point. So let's try a more advanced example here. Installing a real tool or a real image. Whatever. So this will install Bowtie 2. Who is here working with bioinformatics? Okay, so probably most of you know what Bowtie is. And you have the slides, so if you want to copy and paste instead of writing from the screen, you can do that. So this is installing Bowtie 2 using the interactive login, update, install, unzip, and get the zip file of Bowtie 2 with wget, and then unzip this file into /op and create a simulink in /bin, /user/bin for Bowtie. Remove the zip file and exit. By creating this simulink, you put it in the path of the user. After that, Docker commit your username, Bowtie 2, and Docker run Bowtie 2. Now, how many have done with Bowtie 2? Okay. Did you test it with Bowtie 2 version? Okay. Now, I will actually, for the time, I will have to teach you one of two things. And So let's teach you this one because I think it's more important. Now, write the Docker file for both I2. It will contain almost the same commands that you had used, but with the run. Now, this is a good example of how to use the best practice for run. So this is one run command for updating the system and installing unzip, and one run command for all bowtie related things. And at the end, this is another command called env. This is setting an environment variable. So the path you add bowtie to the path. So here we don't need to create the simulink to user bin because we can add to the path easily here. But if you export the path, and this is very important, you can, in Linux, you can export path equals if you want to append something to an environment variable. But this will work only in the current session. So if you exit from the container, this update that you have done to the environment variable is not there anymore. So don't expect if you use export within the container, it will stay in the image because the export command works per session, not permanent. But in the Docker file, when you set an environment variable in the Docker file, then it will be a permanent environment variable which will be set to this value always when the container runs. Now, if you are done with that Docker file, run the Docker build. So if this Docker file is in the current directory, Docker build -t, your username /bowtie2, and then include any tag, and then dot at the end, so that build it in this directory. The same way that you have done it before with the curl vim. Just to make sure that it builds. Now, how many have built bowtie2? Okay. Now, if you have the Docker file, now I will show you how to link the automated build between Docker Hub and that Docker file. How many of you have an account on GitHub? Okay. So if you don't have an account, create an account on GitHub. It is as fast as creating an account in Docker Hub. It also doesn't require credit card or anything. So now I'll show you something, GitHub. Let's sign. My test account, I guess. Now, go to your GitHub and add a new repository. And call it bowtie2 and write bowtie2 test Docker. Okay. Now create the repository. You can create the README file, commit that. Now you will have a bowtie2 repository here, and it is the master branch, and this is a small comment. Now, how many of you have done that? Just create a repository and call it bowtie2 in your GitHub. Now, how many have done with the repository? Okay, now create a new file and call it Dockerfile. And then go and copy this stuff that you had here from the slides to the Dockerfile. And commit. Your Dockerfile should look like this. After you're committing, GitHub discovers that the scripting language and put different color to the special characters of keywords. Okay? Who is done with the Dockerfile? So now we created the Dockerfile under the root directory of bowtie2. So now it has two files, README file and Dockerfile. And please call it Dockerfile with the same spelling as we used before. Now, go to the Docker Hub. Now let's log in with another user. I have a user called Norbis. Yeah. Yeah. This is a test repository that I have. And this is my username. Now, press create here. You will find a choice called create automated build. Now, I will link my Docker repository with my GitHub repository so that whenever I change the Docker file, it will automatically build the image so that whoever wants to make sure that my image is the same as the Docker file, it has to be done this way. So create automated build, it will give you two choices, GitHub or Bitbucket. So link account, choose link GitHub, and then select the first choice. I had that link to another account. Okay. So it allows you only to link a GitHub to one account. So let's log out of that one. So create automated build, GitHub. So first, if you are linking for the first time, it will ask you to log into GitHub with your username and password. Your username, of course, in GitHub is your email, with your email and password in GitHub. And then when you log in, it will show you the repositories that you have in your GitHub account, whether it is your personal GitHub or your organization. So here, this is my personal account, and this is the University of Oslo account. So here we have all of our the things that I have put from GitHub at the University of Oslo. Of course, we have other things which are not shown here. And here are the things that I have in my test account. So here you will find bowtie 2 because you just created it. So who managed to link his or her Docker Hub account with the GitHub account? Okay. Then click on bowtie 2. You can write a description. This is a test for bowtie 2. Public create. Let's call it something else. Bowtie 2. Because I have already an image bowtie 2. Doing a lot of tests. Okay. Now you will find the tags. There is no tags for this image because I have not built it yet. The Docker file is not there yet because now it is linked with your GitHub account. So if there is a link here to the GitHub account. So if I press here, it will take you there, and the Docker file is here. Now, there is something important here is the build settings. The build settings, it needs to ask you where is the Docker file located so that we want the build. So by default, it is located on the root, which is under bowtie 2 repository. And we have it on the root directory here. So it is in the root directory. But if you want to create another directory and put it in the Docker file inside that, you need to include this directory name here. So this one should work. This button is called trigger. Now your Docker Hub account is linked with the GitHub account. Now every few minutes, the Docker Hub will try to build the image for you and push it to the Docker Hub. But if you want to start queuing it now, you can just press trigger. Now you trigger the building. Now we'll find in build details, it was nothing. Now it is queued. It has put in the queue. If you are lucky, it takes few seconds or a minute. If there are millions of people who are trying to build now, it will take more minutes. So now it is queued for building. Come on. Okay, I'm not sure how this will end, so I will show you how it will look like. So let's look for another bowtie image, for example. Let's look here. So after it is built, you will find the contents of your Docker file here in the Docker file. And you will find it on the Docker Hub. And whenever you make a change, you make a commit or a change in the Docker file contents on GitHub, it will trigger automatically a build on the Docker Hub. So your image on the Docker Hub will be always the same as the Docker file that you have on GitHub. So this is how to ensure for people, my image is secure, it is linked with automatic build to my GitHub, so you can use it without fearing of security threats. Okay, still queued, but Maybe there are many people building now, but this is how it will look like. Okay, there are many other things in Docker. I tried my best to tell you about the most interesting stuff. There is one important thing is mounting volumes so that you can have sharing files between the host and the Docker containers so that the files can be seen in both. So check this part of the tutorial, Docker volumes. And also there is some trick for installing Docker on a production system securely, running the Docker containers as the user. So you can check this file. I put it on the GitHub beside the README file. If you are an operational system administrator, this can be useful for you. And if you have any questions, you can send to me later. I hope that was useful, that you learned something new, and thank you very much.